Good morning, everybody, and welcome to the very first episode of Math and Algebra video tutorials. On each of these episodes, I will be showing you a concept, a term, and problems to go along with that concept. I will make all the steps of the problems clear, concise, easy to understand. These videos will be very decisive, brief, and to the point. So let's get to it. Now let's start off small and simple. I'm sure that everybody has heard of the number line. I'm sure that you know what I'm talking about when I, say number line. And I know what you're picturing. Obviously we start out with drawing a line, just like this. And, our mind and eyes go from left to right. So over here we, start, backward and go forward. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it just keeps going on and on further that direction. And a number, a number is bigger than another number if it is a further distance away from 0. So 2 is only 2 places away. And then 5 is only 5 places away from 0. It starts by counting to the number to the right, in this case. And then, count how many places up to that number, including the number itself. The actual number that you're trying to find, how many places it is away from 0. So 6 would be a greater number because it is, bigger than 3 because it's, 6 places, further away from 0. As you go further this way, you get bigger in value. But this is the misconception because a lot of people don't really understand what the real, official, and full-length number line is. This is only some of it. This is only 1/2 of it. In order to understand what that is, then you have to understand what the term integer means. So an integer is any number that is positive or negative. And, really, all numbers are either positive or negative. So these are the signs. A positive sign looks like a lowercase t, or, if you're thinking mathematically, that would be a plus sign. And it is positive. Think of PP, plus, getting bigger, getting better, going higher. If you think about the idea of going, up into the atmosphere, if you're, a diver, deep sea diver, in the ocean, you're going, above the ocean, or, heaven, further up there, or, in terms of money, you're climbing up, you're getting richer, and you're going down, you're getting poorer. So Do not confuse the sign that you use to solve the problem with the sign of the number. So, any positive number looks like any regular number. So, what we consider to be regular numbers are actually positive numbers. So I'd say, 9, 10, 11, all of these are positive numbers. And you don't even need the positive sign to put in front of the numbers. Although you can, but it's just not necessary in order for you to, differentiate and recognize if the number is positive or negative. So, we really don't need these signs. However, that isn't the same tale for negative numbers. So the negative sign looks like a minus sign. When you're subtracting, you're starting with the bigger number and then the smaller number. As with addition, you're doing the opposite. And you're getting less. The answer is less. You're going down. You're getting poor. You're getting more negative. You're going, further, down into the ocean, into hell. All that, these are opposites. So think of adding, subtracting when you think of positive and negatives. So negative numbers would look like negative 10, negative 11, negative 12, and so on. Although this is not the direction that they go in, and I'll talk about that later. But you need the negative sign in front of them to differentiate. So, between negative numbers and positive numbers. So think of weather. Think if you were a farmer digging in the dirt. Or, if you're climbing up a mountain, you're getting, you're going higher. You're, going down the mountain, you're getting smaller. You're going lower. So let's go back to the number line. So let's draw that number line out again so that you can see. And additionally, I'm going to draw these 3 things which you probably know about, and you've probably done problems where you used all 3 of these. We'll come back to that later. But let's just start with the 0. Let's just put 0 in the middle of the number line. That's where it belongs. So let's say that this is the middle of the number line. So, I'm not going to do any explaining for where these things go, because a picture is worth 1,000 words. So we have positive numbers, and we have negative numbers. But what about 0? What about 0? Is 0 positive or negative? Is 0 an integer? It is not. It is not either negative or positive because it is worth nothing. It has no value, so it is neutral. Think about an atom. If we have an atom, I'll just draw it over here for you to see. So if we have an atom, we take an atom, and we have the protons here. And then we draw the orbital. We have all the electrons orbiting around. You know that the protons have a positive charge, pp. Electrons have a negative charge. But what about the neutrons? They go in the nucleus center of the atom with the protons, and they have no charge. They just, put in more bulk. That's a little comparativo there. without getting rid of my beautiful number line. So this is how it looks. So obviously we'd start out, let's start off with the good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, the number line that keeps going on and on. All of these are positive numbers, or regular numbers. You don't call them regular numbers because they are positive. You don't need this sign in front of them to back the numbers up. Over here are all the negatives. But here's the catch. Watch. And so on. So you go further this way, you get less in value. Think of, negative small, positive bigger, and then you keep going further this way, the numbers are greater and you get more in value going to the right. But, if you're thinking about the regular numbers, such as positive numbers, they, go 1, 2, 3, 4, 5, they go from left to right. That's the opposite with the negative numbers because they go from right to left. It doesn't start with 1, negative 1, negative 2, negative 3, negative 4, negative 5, because, greater in value, and that's not true for negatives. So that would mean that, say, negative 6 would be a smaller number than negative 4 because you're going further down. So I think that, makes a lot of sense. Now let's come back to these 3 signs that you looked at earlier. So, a couple ways to think about this. You're looking at this model, shall we say, this collection of signs, and you're thinking, what are these two? I know what this is. You use them in equations. When numbers are equal, they're the exact same. They're equivalent. Or, whatever the amount or reduced to is the same. Maybe when it comes to fractions, things like that. Now there's a couple ways to think about this. One of which is the alligator. Or the alligator's mouth. So think of the alligator's mouth. Doesn't this look like a mouth kind of shape to you? But in order to know what direction that these are really pointing to, now does this make sense? Both of these are arrows. Arrows. The line in the mouth part of the arrow. This one's going further to the right. This one's going further to the left. Bigger, smaller. So that's, that's basically it. So let's do a little, verses here with numbers. So let's say negative 2 versus, positive 3. So are they less than, going further that way, greater than, going further this way, or are they equal to? Well, as you know, the positive numbers are greater than the negatives. So, and 3 is already a bigger number than 2, but you can't use that logic all the time. So, positive 3 would obviously be a bigger number. But how do we answer this? How do we, what number do we, circle, and which mouth do we use? Well, the alligator is a hungry creature. And because it's so hungry, it wants more food than less. It wants to get, the number with more meat, the number with greater value. So, and it can't go over here or over there. It has to go, either here or here, not there or there. So whatever the greater number is, whatever side it's on depends upon the mouth that you're going to use. So 3 is obviously a bigger number. So we would use this mouth here. So 3 is a greater number than -2. You can say that the shape of the mouth is eating in this direction, eating the 3, and I didn't turn it into a negative. So this mouth, has to be eating the bigger number. So that's 1. Now let's do one more so that you can see what I'm talking about. Obviously, let's use another number. 8, and then 1. Which one is, greater than the other? Well, 8, so you would draw the mouth to 8, or positive 8, because both of these are positive. And, 8 is, further, further placements, for you to count from 0 to 8 versus 0 to 1. So, so that would be, how it is. So, that mouth has to go toward the bigger number. You could certainly do it the other way, and it would, look similar for that one. But, so anyway, -10 versus -1, which is the bigger number? Well, 1 is further to the right of -10, so the mouth would go to -1, and then, you follow the arrow and you go further left to -10. So that is all fine and dandy when it comes to understanding positive and negative numbers. Now, you're going to understand how to solve problems with positive and negative numbers using the 4 solving signs that you all know very well, which are addition, subtraction, multiplication, division. When you're adding, you use the addition sign, you're getting bigger. When you're subtracting, you're using the subtraction sign, you're getting smaller. Multiplication is double addition, so you're getting double bigger. And division is another form of multiplication, but it is the in-between backwards multiplication. So what is the number lurking in between? So if you have a number of a multiplication problem, and then the answer, what's the number, that's missing? What's the other part of the problem? So addition and multiplication are linked. Both of them, are getting, both of those are getting bigger. If you think about, you have your file and then you have your L, or maybe file and then L, and then, subtraction and division are linked. You have your, earth and your water, vice versa, they're getting smaller. Or if you think about the four subjects, you have your English, you have your history, and then you have your, subtraction, you have your math, and then science for division. I don't know. I'm kind of going off and off about these. I think that you get it. So let's move on. So obviously you know all four of these very, very well. So let's try to fix that. So I'll write the signs up here so that you can see, just to have them, positive sign, negative sign. So let's just start out simple. So 6 plus 3 equals, well obviously it's 6 plus 3 equals 6, 7, 8, 9. So you'd solve it like a regular problem. Now, integerally speaking, if I had to, make up a word, both of these are positive. When you have two numbers in your problem that are the same sign in an addition problem, you add. And then the answer would be, a bigger number. It doesn't matter, with subtraction or, addition, if you put the bigger number first or the smaller number second or vice versa. Unless, of course, with subtraction, you're doing that with multi-digit. Then So, but anyway, and then you just keep to the, you keep to the sign of the numbers with your answer. Now, opposite, inverse comes opposite. You detect what, the code that I was saying. Let's do that same problem again. So negative 6 plus 3 equals. Well, you're wondering, okay, well, 6 plus 3, well, no. And you have a problem and the two signs are different. The two signs are opposite. So one's a negative, one's a positive. And when you're adding, you do the opposite of addition. So when you have a negative 6 and a positive 3, in this case, you would subtract. So 6 minus 3 is 3. And what would your answer be? Positive or negative? Whatever the sign of the bigger number is. Oh, well, we learned about number lines. The bigger number is 3 because it's further to the right. And it's in the positives. Well, forget about that for now. Forget about it. Because just think generally. Pretend that, there's no negative sign here. Just, think, without the integers of a number, 6 is a bigger number than 3, obviously. So, we would use the sign of the in general bigger number, which is a negative sign. So, our answer would be negative 3. Just as simple as that. Now, let's do that same problem again, but let's make the 3 a negative. Well, both of these are negative. So, negative versus negative equals negative. So, spoilers. Both of these are the same signs, which are both negative, so we add. When the numbers are the same signs, we add 6, 7, 8, 9. So, and both of these are negative, so we just keep to the same sign, negative 9. So that's how you solve those problems. So, remember that a positive, we have a positive. So, let me write this out, So positive, and then a negative equals a negative, or vice versa. Negative, negative equals negative. Positive, positive just equals, amounts to more positive. So you've got how to solve the addition problems. Now you're going to learn how to solve subtraction. So, let's just do a normal one. So 9 minus 3. Oh, let's do another number. I feel like I use 3 a lot. Let's do 9 minus 4 equals. Okay, you just solve it like, normal problem. 9, 7, 6, 5, 9, 8, 7, 6, 5. That's not the same. That's not the right answer for that. Well, you can't use that logic. You need to use another logic when you're solving integer problems. Sometimes you don't know when you're solving a regular problem versus an integer problem. It's all about, showing the work of that. So, when you're adding, two positives, you get a positive. These are, two positive numbers, and you're just using the subtraction sign. But there's a little method that I learned how to solve subtraction problems using integers. It's called leave, change, change. And this basically draws out the order of how you're going to go. So you're going from left to right. So you're starting with this number, then you're going to the sign that you're solving for, and then the next number. So you're going, these are, coordinates, and just line them up. So left to right. So you're leaving this number, but then you're changing the sign that you are solving for. So it's the opposite of subtraction, addition. Change it to an addition sign. And there's still that change that's still there. So we need to change the 4. What's the opposite of a positive 4? Negative 4. So then we go back to solving it like an addition problem. And we know that when we have one positive, one negative, we subtract. So 9 minus 4, 9, 8, 7, 6, 5. And the bigger number, which, obviously, integerally speaking, is to the right positive, further away from 0. And just in general, so our answer would be positive 5. Okay, and so let's do another, let's do that same one. So negative 9 minus negative 4. So we have this leave, change, change, or if you had to abbreviate it, LCC, for short. So you leave this negative 9, you follow the steps from left to right. So you leave the negative 9. You change the sign that you're solving for, so it's the opposite of subtraction, addition. It's really, really smooth going, as you can see, and then changing the sign of the number to the right. So opposite negative 4 is positive 4. And both of these are different signs, 9, 8, 7, 6, 5. And in general, not integerally speaking, 9 is a bigger number than 4, so what's the sign for that number? Negative. So our answer is negative 5. Alright. 2 down, 2 to go. And I'm actually going to kind of put a check mark next to the ones that we did. Well, that looks like a V. It's not perfect, but I think that you get it. Oh, let's do that again. So now we have multiplication and division. So the rule is for multiplication is when you have two, actually let's not go there. So, division and multiplication are another version of, division and subtraction, are a different version of multiplication and addition. So let's just do a simple problem. 6 times 8. Well, that would be 48. Obviously, we're solving that like a regular problem. But the rule is, when you have two numbers that are the same sign, when you have both that are the same sign, both are, say, maybe positive or negative, your answer would amount to a positive, because positive plus positive equals, two positives equal another positive. So 3 is the magic number. There's 3 parts to it. Let's do that same thing again. Negative 6 times 8. Well, you have a negative 6 and a positive 8. Both of these have different signs. So when the two numbers have different signs, when one has one sign and the other has the other sign, your answer would be a negative. So negative 48. And no, you can't look at the sign of the lesser number for this one. So negative 48. When you have negative 6 times negative 8. Well, both of these are the same sign, so your answer would be positive. Forget about the sign for these numbers. So again, that would be positive 48. And that rule applies the exact same if you're solving for division. So let's take a division problem, 10 divided by 5. Well, 10 divided by 5, if you think about, 5 times what equals 10 in multiplication, obviously that'd be 2. You'd answer like a regular problem. But again, that rule still applies. Both of these signs are positive.